Welcome to this Deep Focus Explainer. Go ahead and take a slow, deep breath. Settle into your space. Today, we're locking in on the exact values of trigonometry for the Cambridge AS and A-Level Mathematics 9709 syllabus. We are going to calmly deconstruct the exam structure, build your methodological confidence from the ground up, and systematically secure every possible mark without any of that heavy cognitive overload. We're stepping away from frantic memorization and moving into a space of pure, serene, logical architecture. So get comfortable, clear your mind, and let's dive right into this. Here is our steady, deliberate trajectory for today's session. 1. Core principles. 2. Technical methodology. 3. Systematic processing. 4. Examiner warnings. And finally, 5. Critical analysis. Section 1. Core principles. Let's establish a calm baseline of knowledge. I want you to just absorb the incredible, flawless symmetry of these core mathematical values. So often, students approach trigonometry with this underlying sense of anxiety, relying heavily on their calculators as a crutch, frantically punching in numbers when they should be relying on their own mental clarity. But when you look closely at these foundational exact values for 30, 45, and 60 degrees, you realize it's all just a beautiful, predictable pattern. Think about sine. The values smoothly, calmly progress as the angle increases. You start at 30 degrees with a clean, simple 1/2. Then, at 45 degrees, you glide up to root 2 over 2. And at 60 degrees, you reach root 3 over 2. It's like climbing a perfectly spaced ladder. 1, root 2, root 3. Now observe how cosine beautifully mirrors this exact sequence, just in reverse. It steps down exactly as sine steps up. And tangent? Well, tangent is simply the sine divided by the cosine. There's no magic here, just pure logic. When you commit these core patterns to memory by understanding their symmetry, rather than just brute forcing isolated data points, you completely remove massive amounts of cognitive friction. You no longer need to pause and disrupt your flow to calculate during a high-pressure exam. Instead, you just calmly reach into your mental toolkit, pull out the exact value you need, and effortlessly carry on with your proof. Now let's talk about how you apply these values, because this is where the true elite candidates separate themselves. Notice the stark contrast between analytical depth and superficial breadth. The Cambridge Assessment Framework explicitly, definitively rewards you for logical, structured reasoning, that beautiful analytical depth, rather than just having a superficial breadth of scattered memorized facts. I want you to imagine two scholars we work with often. Let's call them Alex and Sam. Now, Alex is highly precise, a really hard worker, but Alex tends to crowd their page layout with unstructured facts. They know every formula, but they just throw them onto the paper in a panic. Sam, on the other hand, is incredibly creative and dynamic, but sometimes loses focus on the specific command words. Both approaches lead to lost marks. It is simply not enough to know that the sine of 30 is 1/2. Superficial breadth won't save you when the question demands integration across multiple topics. Analytical depth means knowing exactly why that 1/2 matters when you are calmly deconstructing a complex trigonometric identity or finding points of intersection on a curve. A top-tier candidate builds a clean, structured approach to mathematical proof that absolutely prevents them from running out of time. They don't rush, they don't panic, they analyze. Section 2, Technical Methodology. Let's deploy the procedural framework. Listen carefully to this direct alert from the principal examiner. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. This simple statement represents a massive, fundamental shift in your exam mindset. Your primary goal in the exam room is actually not to scramble frantically for a final numerical answer. Let me repeat that because it's so important. You are not just hunting for a number. Your goal is to clearly, elegantly, and explicitly prove your structural process. The examiner isn't just grading your calculator skills, they are grading your ability to communicate mathematically. Think of your examiner as someone who desperately wants to give you points, but you have to show them exactly where to put those check marks. When you just write down a final answer, you are essentially gambling everything on a single, fragile endpoint. But when you write out your steps, with clean spacing and clear logic, you are building an undeniable case for your own success. You are proving that your mind works systematically. This brings us directly to what we call the method mark strategy. This is the deliberate protocol where examiners award marks for an explicitly clear, logical process. Imagine our two scholars, Alex and Sam, in a shared digital workspace right now. They're tackling a brutal, high-tariff trigonometric proof. Alex immediately maps out textbook definitions, trying to skip steps to reach the final answer faster. But Sam hits the brakes. Sam challenges the framework, saying, wait, if we don't show the exact substitution here, we lose the method mark. They debate the layout, and eventually they realize they need a structured framework. In essay writing, you might know the Peel structure: point, evidence, explanation, link. In mathematics, we adapt this: principle, equation, execution, logical link. You state the principle, you set up the equation, you show the flawless execution of the substitution, and you link it to the final result. By leveraging this exact strategy, you aggressively protect your overall score. Even if you hit a structural roadblock mid-calculation, even if you accidentally drop a negative sign in the very final line of algebra, your layout clearly demonstrated the correct substitution. Because you explicitly showed that you knew the cosine of 60 is 1/2, the examiner happily awards the method mark. It is your ultimate unshakable safety net. Section 3. Systematic processing. The exact procedural sequence to maintain focus. Let's just breathe and refocus for a moment. Before we write out our final top band sequence, I want to make sure your daily study dashboard is completely optimized. If you're finding this deep focus approach helpful, I want you to subscribe to Ace the Exams at Ace the Exams right now, and go ahead and enable all notification alerts. Whether your target is an IGCSE, an O-level, or securing that A-level A-star, this channel is your dedicated weekly space for stress-free exam mastery. Okay, let's get back to the sequence. By internalizing this standard 5-step flow, you completely eliminate mid-calculation panic. Step 1, identify key elements. Step 2, apply relevant principles. Step 3, execute analysis with brilliantly clear working. Step 4, verify results. And Step 5, present in the appropriate format. You methodically process complex data just like a senior examiner expects. If your working ever gets disorganized, or you feel that sudden spike of adrenaline and lose your train of thought under time pressure, you don't freeze. You simply hit the channel pause in your mind, fall back on this reliable 5-step sequence, and restore absolute, beautiful balance to your mathematics. We call this first step the mindful scan. Imagine a highly complex Cambridge exam paper sitting right in front of you. The clock is ticking down. You don't just dive in and start scribbling. The crucial point here is to start with a mindful scan of the prompt to deliberately peel back the filler words and isolate the exact assessment objectives. When you look at a question that asks you to solve an equation like 2 sine theta cosine theta equals sine theta, you first deconstruct it. Extract the relevant data, like the specific domain of the angle. Is it between 0 and 360 degrees or 0 and pi? Then select your analytical framework. Will you factorize? Will you divide? Here's a crucial hint that saves countless grades. You rarely, if ever, want to divide by a trigonometric variable because you risk completely deleting a valid solution from existence. Instead, factorizing is your optimal, serene path forward. You pull everything to one side, you factor out the sine theta, and suddenly, a chaotic equation splits into 2 beautiful, simple, manageable pathways. You actively interpret relationships, line by careful line. Section 4. Examiner warnings. Identifying and sidestepping the hidden traps. Let's step into the visual practice arena. I call this challenge 2, the imperfect answer. Picture a flawed paragraph of student work on the screen. Let's say Sam wrote it during a mock exam. The math looks okay at first glance, but right in the middle, the structural discipline completely breaks down. These 3 pitfalls on your screen, distilled directly from years of Cambridge principal examiner reports, are exactly where students bleed high tariff marks. Mistake number 1. Confusing cause and effect. This often manifests as misapplying an identity, assuming something is true before proving it, or working backward incorrectly from a show that question. Mistake number 2. Forgetting to check format and presentation. Did the command word ask for exactly 3 significant figures? If the prompt demands exact values, and you write down a long, messy decimal straight from your calculator, you immediately lose marks, regardless of whether that decimal is technically equivalent. And mistake number 3. Providing answers not specific to the context given. If the question specifically outlines that the angle is obtuse, the context dictates that the cosine value must absolutely be negative. Missing that context makes your perfectly calculated exact value practically useless. And that brings us to the ultimate directive. Never, ever forget the #1 rule across all examiner reports. All your precise values and analytical frameworks must lock perfectly into the specific context given. Whether it's ensuring your calculator is strictly set to radians when calculus is involved, or rigorously, systematically checking the specified quadrant using a CAS diagram, context dictates everything. A correct mathematical value applied in the wrong context is considered a fundamentally flawed evaluation of the evidence by the examiner. You have to read the specific parameters of the command words. If it says analyze, you break it down. If it says evaluate, you must judge the validity. Apply your calm, structured knowledge precisely where it belongs. Section 5, Critical Analysis. Reaching the absolute highest evaluative levels. For our final polish review pass, let's look at how the top 1% of candidates secure those pristine, high-scoring blocks of working. They do it through critical analysis. To reach this level, you must calmly evaluate the quality of your own evidence and identify any limitations in your approach as you write. Top-scoring candidates constantly question their own assumptions. When solving a complex trigonometric equation, they pause and ask themselves, am I assuming this angle must be positive without justification? They actively consider alternative interpretations. For instance, when dealing with a quadratic in terms of tan theta, they meticulously evaluate both the positive and negative roots, rather than just blindly accepting the first one their calculator spits out. And crucially, they justify their decisions by literally writing down brief, clear notes next to their math. A simple, confident statement like, rejecting the negative root as theta is explicitly stated to be acute, shows immense analytical maturity. They don't just calculate like machines, they evaluate the alternatives and provide justified mathematical statements for a flawless, well-argued method. As we bring this strategy session to a close, let's distill this entire masterclass into our core focus pillars. The mindful question scan to decode the prompt, the steady, rhythmic marks per minute flow formula to control your timing, and the final polish review pass to ruthlessly review your context. The exact values of trigonometry are simply your tools, but your calm, deliberate methodology is what actually builds your final score. So I have a question for you. The next time you face a massive, high-tariff trigonometry puzzle, will you rely on frantic, stressful calculation, or will you trust your new structural framework to logically guide you to the perfect answer? Think about that. Before you close out this focus session, I want you to subscribe to AC Exams. At AC Exams, click that notification bell so you don't miss our future focus deployments, and drop a comment below right now telling me the specific subject, tier, and target grade you are currently meditating on. Stay calm, stay focused, and trust your process.